Hello friends, greetings of the day. Today we will discuss about steroid hormone biosynthesis and congenital adrenal hyperplasia. Steroid hormone biosynthesis, cholesterol first enters into the cytoplasm. From cytoplasm it enters into the mitochondria of the cell. The biosynthesis of the steroid hormones will be in the mitochondria. So the cholesterol from the cytoplasm enters into the mitochondria with the help of the enzyme called STAR. Okay, steroid hormone autoregulatory enzyme. So this will help the cholesterol to enter into the mitochondria. Okay, and when it enters into the mitochondria, 11 alpha hydroxylase enzyme or steroid cyclin cleavage enzyme, it also called as cyclin cleavage enzyme. This will convert cholesterol into pregnenolone. Okay, the steroid hormone synthesis you can divide into 3 vertical arrows. First is mineralocorticoid pathway, second is glucocorticoid pathway, third is androgens pathway, and the first 2 horizontal arrows will also synthesize the androgens. Okay, first 2 horizontal arrows will synthesize androgens, and the first vertical line will synthesize the mineralocorticoid pathway, second vertical line will synthesize the glucocorticoid, third vertical line will synthesize androgens. First 2 horizontal lines will also synthesize the androgens. So first we will go to the mineralocorticoid pathway. From cholesterol, with the help of cyclin cleavage enzyme, also 11 alpha hydroxylase, it is also called as CYP11A. From cholesterol pregnenolone is formed. From pregnenolone, with the help of 3-hydroxy beta hydrogenase HSG3 beta, progesterone is formed. From progesterone, with the help of 21 alpha hydroxylase, 11-deoxycorticosterone is formed. From 11-deoxycorticosterone, with the help of 11-beta hydroxylase 2, also called as aldosterone synthase. Okay, aldosterone is formed. This is the mineralocorticoid pathway. Okay, and next horizontal pathway, next vertical pathway, from pregnenolone, for aldosterone it converts into progesterone, but for cortisol, secretion of cortisol, glucocorticoids, the pregnenolone converts into 17-hydroxypregnenolone. Okay, it converts into progesterone. Here it converts into 17-hydroxypregnenolone with the help of 17-alpha hydroxylase enzyme. Okay, from 17-hydroxypregnenolone, same like here, with the help of HSG3 beta 2, that is 3-beta hydroxysteroid dehydrogenase, 17-OH pregnenolone converts into 17-OH progesterone. Here the normal pregnenolone converts into progesterone, normal progesterone, when the mineralocorticoid pathway, but in cortisol there is need of 17-OH. Okay, 17-hydroxy and should be provided for cortisol synthesis. So for attaining 17-hydroxy, the enzyme help is 17-alpha hydroxylase. Same from pregnenolone, 17-OH pregnenolone to progesterone, like here the enzyme help is 3-beta hydroxysteroid dehydrogenase. Okay, from 17-hydroxyprogesterone to 11-deoxycortisol, to same like here 21-alpha hydroxylase is helpful to convert progesterone into deoxycortisol, 17-hydroxyprogesterone into 11-deoxycortisol. Here it is converted into 11-deoxycorticosterone. Here it is converted into 11-deoxycortisol. Okay, it is androsterone, that's why corticosterone, here cortisol, so it is deoxycortisol. From 17-OH to cortisol, here from normal progesterone to corticosterone. Okay, the enzyme help is 21-alpha hydroxylase. Okay, and from 11-deoxycortisol, the cortisol is formed with the help of 11-beta hydroxylase enzyme. From cortisol, cortisone is formed vice versa by 11-beta hydroxysteroid dehydrogenase enzyme. Okay, and if you further go into horizontally, in this steroid hormone in the first two horizontal lines, what we are told, the androgens are produced. Here in the horizontal lines, the enzyme helpful is same enzyme 17 alpha hydroxylase. From 17-OH pregnenolone, the dihydroepiandrosterone DHEA is formed with the help of 17 alpha hydroxylase. From 17-OH progesterone, androstenedione is formed with the help of 17 alpha hydroxylase. And from androstenedione can also be formed from dihydroepiandrosterone, like same HSG3 beta 2. Here also HSG3 beta 2 is helpful to convert DHEA into androstenedione. Androstenedione is converted to testosterone with the help of HS17 beta hydroxysteroid dehydrogenase. Okay, 17 beta hydroxysteroid dehydrogenase. In the help of that enzyme, androsterone is converted into testosterone. This is the nutshell of the steroid hormone synthesis. In this steroid hormone synthesis, if some enzymes, mostly congenital adrenal hyperplasia is the problem for the secretion of the cortisol. Okay, so cortisol will be because of different enzyme deficiencies, cortisol secretion will be, cortisol synthesis will be dearranged, and it will lead to the activation of ACTH. Because the cortisol is deficient, it will lead to the positive feedback mechanism onto the ACTH, adrenocorticotropic hormone. This will lead to the hyperplasia of the adrenal gland. But the cortisol is not synthesized, but other pathways like aldosterone and androgen pathway will be overreactive, and there will be different manifestations of this overactivity of all mineralocorticoids, aldosterone and androgens. This pathway will be impaired. Because of that, ACTH will be positively activated, and it will cause adrenal hyperplasia and cause overactivity of the mineralocorticoids and androgens. This will lead to many manifestations, which we will discussing further after in the next few minutes. So this is the basic concept. Due to impaired production of cortisol, the aldosterone and testosterone, because whenever there is a block of these enzymes, instead of coming to this pathway, these enzymes will go to the other pathways and help in and will increase the production of these, abnormally increase the production of these mineralocorticoids and androgens. This is the basic concept. Now we will go to the congenital adrenal hyperplasia. Congenital adrenal hyperplasia means in this steroid synthesis pathway, there is deficiency in the mutation of one of the enzymes. There will be mutation of one of the enzymes. This lead to some of the clinical manifestations. There are few diseases in the congenital adrenal hyperplasia, like 21 alpha hydroxylase deficiency, 11 beta hydroxylase deficiency, 3 beta hydroxysteroid dehydrogenase deficiency, 17 alpha. So like this different enzyme deficiency, then there will be different clinical manifestations. Most common is 21 alpha hydroxylase deficiency. So 21 alpha hydroxylase deficiency is the most common one. You can see 21 alpha hydroxylase will help to convert progesterone into 11-deoxycorticosterone in the mineralocorticoid pathway. Okay, and 11-deoxycortisol, 17 hydroxyprogesterone to 11-deoxycortisol in the synthesis of the glucocorticoids. So this enzyme will be helpful in both the synthesis of this is 21 alpha hydroxylase. It will be helpful in the synthesis of both cortisone and also aldosterone. Okay, if this enzyme is deficient, there is a block here. Okay, 21 alpha hydroxylase. The steroid and mineralocorticoid and the glucocorticoid synthesis cannot go further this pathway. This is because of that these pre-products will increase, and they will go to the other pathways like this horizontal pathways, first two horizontal pathways, and they will lead to the increased synthesis of these androgens. This is 21 alpha hydroxylase deficiency. Because of the block here, the mineralocorticoids and the glucocorticoids are not synthesized, but because of the pre-products, all these enzymes will all these products will lead to the will increase and will lead to the hypersynthesis of these androgens. And this is the basic concept of 21 alpha hydroxylase deficiency. This is the most common most common most common most common form of congenital adrenal hyperplasia, which is 75%. Okay, there are two types, classic and non-classical. Classic is the salt wasting form, okay, which is which presents immediate in the newborn period. Okay, this is the very dangerous form. Non-classic form presents at the time of puberty. Okay, when the aldosterone and cortisone is deficient, because aldosterone will help in sodium and water retention, and potassium sodium and water retention, and potassium excretion. So when aldosterone is deficient, the sodium and water will be lost in the urine. That's why it is called salt wasting type. When sodium and water are lost more in the urine, it will lead to shock, means BP will be very less and will lead to hypovolemia and also hyponatremia, because sodium is lost. Hypovolemia leading to shock, and because potassium excretion is done by aldosterone, if it is deficient, the potassium cannot be excreted, it will lead to hyperkalemia. And because I already told you, because this cortisol, when it is not synthesized, it will lead to positive feedback on the ACTH. Because of ACTH, the side effect is hyperpigmentation of the skin, and there will be hypoglycemia because glucocorticoids are not formed, and ambiguous genitalia are seen in the females, because these androgens, I already told you, these first two horizontal pathways will be overreactive, and they will increase the production of androgens, and because these androgens are very high, they will lead to the ambiguous genitalia in the females. Okay, because androgens are the male hormones. If the females have these more androgens, then it will lead to ambiguous genitalia. Okay, and will also lead to the precocious puberty in the boys. Because of the excessive androgens, it will lead to precocious puberty, means early puberty, early virilization in the boys at the time of puberty. And also in this is the classical in classical form, which presents in newborn period. It will lead to hyperkalemia, hyponatremia, shock, hyperpigmentation. So baby will come with hypoglycemia and shock and hypotension with hyperkalemia, hyponatremia. So then you should think, and also metabolic alkalosis, because so metabolic alkalosis, because hydrogen excretion is also done by this metabolic acidosis, because hydrogen excretion is also done by this aldosterone. If it is deficient, hydrogen cannot be excreted, and it will lead to metabolic acidosis. So hyperkalemia, metabolic acidosis, hyponatremia, shock, hyperpigmentation, hypoglycemia will be seen in the children in the neonatal period, and ambiguous genitalia can be seen in the female bones in the neonatal period. You can suspect this as 21 hydroxylase deficiency. And the non-classical form, I told already, it's two types, classical and non-classical. Non-classical form presents during puberty. It will lead to amenorrhea in girls, because of these increased androgens, they will lead to amenorrhea, and amenorrhea in girls, and precocious puberty in boys. Okay, in the non-classical form. Okay, to investigate these children with ambiguous genitalia, if you find, then you should send 17 OHP levels to find out this 21 hydroxylase deficiency. Because if 21 hydroxylase is deficient, these 17 OH progesterone levels will be very high. Okay, because this it is blocked here, it will be very high. So 17 OHP levels will be very high. Because mineralocorticoids and glucocorticoids are very less in this disease. mineralocorticoid and glucocorticoid replacement should be done, and surgery should be done for ambiguous genitalia like vaginoplasty and clitoral resection. Okay, this is about 21 hydroxylase deficiency. This is most common form of congenital adrenal hyperplasia. And we will go to 11 beta hydroxylase deficiency. 11 beta hydroxylase helps in conversion of 11-deoxycortisol to cortisol. Okay, 11-deoxycortisol to cortisol. If this enzyme is deficient, the 11-deoxycortisol levels and also other pre-products will be elevated. So here the cortisol biosynthesis will be dearranged, but these pathways, mineralocorticoid pathway and the androgen synthesis pathway, will be hyperreactive, and over secretion of mineralocorticoids and androgens will be seen. So because when mineralocorticoids are elevated, aldosterone is elevated. Due to this, sodium and water retention will be there, and it will lead to hypertension and also hypokalemia. So in 11 beta hydroxylase, there will be impaired cortisol synthesis, excess aldosterone will be there. So only this cortisol glucocorticoid pathway will be dearranged. So androgens and mineralocorticoids will be excess. Because of excess aldosterone, hypertension will be there, and because of excess androgens, ambiguous genitalia in the girls and precocious puberty in the boys, same like 21 hydroxylase, will be seen. So mainly here hypertension is the main clinical feature, because the so when the child with ambiguous genitalia with hypertension, or male child with precocious puberty comes with hypertension, you should suspect this 11 beta hydroxylase deficiency. Okay, here cortisol is deficient, cortisol synthesis is dearranged, and aldosterone and androgens will be excess. Okay. In next is 3 beta hydroxysteroid dehydrogenase deficiency. If you see the enzyme 3 beta hydroxysteroid dehydrogenase, it will help in all the three vertical pathways. Okay, in mineralocorticoid, see here, from pregnenolone to progesterone, from 17-hydroxypregnenolone to progesterone, from deoxyepiandrosterone to androstenedione. So three vertical pathways need. It is the first step in all the three vertical pathways, HSG 3 beta 2, first step. So if this enzyme is deficient, all the three vertical pathways, mineralocorticoid pathway, glucocorticoid pathway, and also androgen pathway will be dearranged. Okay, also the second horizontal pathway will also be dearranged, leading to deficiency of the testosterone. Only pathway patent here is first horizontal pathway, which helps in production of dehydroepiandrosterone, dehydroepiandrosterone, DHEA. This DHEA is not a potent androgen. It is very less potent than testosterone. So the boys need testosterone for their development, for the development of their external genitalia and also their sex organs. So but this dehydroepiandrosterone is very less potent. So in females, because of this excess dehydroepiandrosterone, these females will be, because this is also type of androgen, these females will be virilized, means they will have ambiguous genitalia, some form of male form of ambiguous genitalia in females. And also in males, there will be also ambiguous genitalia, because testosterone is not formed. Testosterone is needed for the for the development of the male sex organs. So this dehydrosterone, because of dehydrosterone excess and testosterone deficiency, there will be ambiguous genitalia in the both males and females. Okay, females because of this androgen, excess androgen, dehydroepiandrosterone. Okay, so here in the first two there is ambiguous genitalia in only males, in only females is seen, but here in 3 beta hydroxysteroid dehydrogenase deficiency, the ambiguous genitalia are seen in both males and females. Here the males are not affected because the testosterone synthesis in these two pathways is the testosterone is produced more but not but it is produced more, but it's not deficient. So in these two pathways males are not affected, only females are affected because of excessive androgens. Males are also affected, but there is no ambiguous genitalia, but they have precocious puberty in first two. But here in males and females both have ambiguous genitalia because of excessive DHEA and reduced testosterone. Okay, so aldosterone, cortisol and testosterone synthesis. So three pathways are dearranged, impaired, leading salt wasting and shock. Because aldosterone is less, this will lead to salt wasting and shock. DHEA levels are increased because of that ambiguous genitalia in both males, undervirilized due to reduced testosterone, and in females overvirilized because of increased DHEA levels. So in both males and females there is ambiguous genitalia and 3-beta hydroxysteroid dehydrogenase deficiency. And next is 17 alpha hydroxylase deficiency. 17 alpha hydroxylase, I have told you, it is helpful in the first two horizontal pathways. See, 17 hydroxylase, 17 alpha hydroxylase, 17 alpha hydroxylase, and also here also 17 alpha hydroxylase, 17 alpha hydroxylase. So it is completely useful for the horizontal production of horizontal pathway hormones. What are the first two horizontal pathway hormones? I also already told you, androgens. So the androgen synthesis will be impaired, okay, in the 17 alpha hydroxylase deficiency, whereas and also cortisol synthesis is also impaired because these 17 hydroxyprogesterone and 17 hydroxypregnenolone not produced. This cortisol is also not, this pathway is also not synthesized. Cortisol is also not synthesized, and also androgens also not synthesized because the block is here. Block is here, so all these hormones are not synthesized, both androgens and cortisol. Only working is mineralocorticoids. Okay, aldosterone is working because excessive aldosterone, these are here also there will be hypertension. Okay, same like 11 beta hydroxylase deficiency, in 17 alpha hydroxylase deficiency also sex steroid hormones and cortisol. Sex steroid hormones and cortisol are deficient, whereas aldosterone is more. Because of that there will be hypertension. The treatment is sex steroids and cortisol replacement. Okay, because they are deficient, sex steroid hormones and cortisol replacement should be done, and aldosterone excess leads to hypertension. Okay, because this pathway is patent, aldosterone excess lead to hypertension. Okay, next is congenital lipoid adrenal hyperplasia. This is because of the mutation in the STAR enzyme. Because of the mutation in the STAR enzyme, cholesterol cannot enter into the mitochondria, and all this cholesterol will accumulate in the cytoplasm of these cells, adrenal cells. This will lead to the lipoid. This will lead to increase due to the excessive cholesterol in the cells. It will be fully accumulated with lipids, and it will lead to hyperplasia with the lipids. That's why it is called as congenital lipid adrenal hyperplasia, because if the cortisol only does not enter into mitochondria, all this process will be impaired. So complete deficiency of aldosterone, cortisol and also testosterone will be seen. So they will be having salt wasting, congenital adrenal hyperplasia with shock, same like 21 alpha hydroxylase deficiency. Along with that, in 21 alpha hydroxylase, only two vertical pathways are dearranged, but in this also androgens also dearranged. Because of this there will be ambiguous genitalia in males, because androgens are not synthesized. Androgens are required for the development of the testes and penis, so there will be ambiguous genitalia in the males. And because all the androgens are deficient, or because estrogen and progesterone are also female androgens, they are also not produced properly because this steroid hormone synthesis is deficient. So in females there will be no ambiguous genitalia, only in males there will be ambiguous genitalia because of impaired testosterone synthesis. But in females there will be ovarian failure. the puberty, poor puberty, and the ovarian failure will be seen, because estrogens and progesterones will also be not synthesized. So pure puberty and ovarian failure will be seen. Okay, ambiguous genitalia in the males, and poor puberty and ovarian failure will be seen. And also aldosterone deficiency will lead to salt wasting form of CAH, means like same like 21 hydroxylase. There will be hyperkalemia, shock, hyperpigmentation, hypoglycemia. Okay. Next is P450 oxy P450 hydrox P450 oxidoreductase deficiency. Okay, these 21 alpha hydroxylase and 17 alpha hydroxylase both are P450 enzymes. So in this P450 oxidoreductase deficiency, both 21 alpha hydroxylase and 17 alpha hydroxylase deficiency will be seen, and this will lead to the clinical features combine of 21 hydroxylase and 17 alpha hydroxylase deficiency. Okay, there will be ambiguous genitalia in both males and females. Here there will be ambiguous genitalia in both males and females, and in mothers there will be virilization. In the mothers with these neonates with these P450 oxidoreductase enzyme deficiency, during pregnancy there will be virilization of the mothers. It's called Antley-Blixer syndrome. Next is aldosterone synthase deficiency. This 11 beta hydroxylase 2, it's called aldosterone synthase deficiency, which will help in the synthesis of aldosterone. So there will be because aldosterone is not synthesized, there will be hypotension. Same hypotension will be there, hyperkalemia will be there. Okay, metabolic acidosis will be there. Okay, salt and water loss will be there. Okay, this is aldosterone synthase deficiency. Next is P450 side chain cleavage deficiency. P450 side chain cleavage deficiency means, I already told you, P450 side chain deficiency is CYP11A deficiency. Same like star, there will be complete dearrangement of all these enzymes. So the clinical features will be same like star enzyme mutation. So there will be salt wasting form of CAH, and also cortisol will be deficient, androgens will be deficient. So the males will be with kind of ambiguous genitalia, and females in the time of puberty they will have poor same like star or poor puberty and ovarian failure will be seen. Same like star mutation but no lipoid hyperplasia. Some important points to remember is in this congenital adrenal hyperplasia, 21 alpha hydroxylase deficiency is the most common form. It is a 75% form, and in hypertension is seen in 11 beta hydroxylase and 17 alpha hydroxylase deficiency. Okay. In 3 beta hydroxysteroid deficiency, the ambiguous genitalia are seen in both males and females. Also in P450 oxidoreductase and P450 side chain cleavage, there will be ambiguous genitalia in the in the congenital lipoid adrenal hyperplasia, and P450 side chain there will be ambiguous genitalia in the males. Whereas in P450 oxidoreductase and 3 beta hydroxysteroid dehydrogenase, there will be ambiguous genitalia in both males and females. In 3 beta hydroxysteroids and P450 oxidoreductase, both males and females have ambiguous genitalia. In P450 side chain cleavage, like 11A, and congenital lipoid adrenal hyperplasia, only males will have ambiguous genitalia. In the first two, 21 alpha hydroxylase and 11 beta hydroxylase, the females will have ambiguous genitalia. Okay, please remember these things. If you have this is the nutshell of the congenital adrenal hyperplasia. The treatment will be whichever hormone is deficient. If the mineralocorticoids are deficient, then mineralocorticoid replacement like fludrocortisone can be replaced, and for glucocorticoid deficient, glucocorticoid should be replaced, and ambiguous genitalia should be treated. Okay. And for hypoglycemia, glucose should be supplemented. For shock, the sodium and water should be retained. So there should be symptomatic and symptomatic treatment. Okay, this is about nutshell about congenital adrenal hyperplasia. If you have any doubt, please comment, and please like my video and share my videos and subscribe to my channel. Thank you very much.